Today we're going to start talking about graphing y equals ax squared plus bx plus c. In the previous two lessons, we kept seeing that the vertex was either at 0, 0 in the y equals ax squared lesson, or it started to move up or down, but still on the y-axis. So with that plus c, it either went up if it was a positive number or it went down if it was a negative number, but the vertex always stayed on the y-axis. So the axis of symmetry was always x equals 0. In this lesson, we're going to start seeing what happens when the bx comes into play, because it obviously starts changing things a little bit more as we are going. So the first couple of things. So the graph opens up when we have a is greater than 0. We learned about that in the very first one. And it opens down when a is less than 0. So if that a in front of the ax squared is a positive number, we know that our parabola is opening upward. If it is a negative number, we know it's opening downward. The y-intercept, which we haven't really had to deal with a whole lot at this point, is always going to be our c value. So let's think about that for a second. So if the y-intercept, we know the y-intercept, the x of all y-intercepts, the x value is always 0. So in the ax squared only lesson, 2 lessons ago, it was only ax squared. So when I plugged in a 0, the ax squared also became 0. In the ax squared plus c lesson, then the c, once the ax squared disappeared, became your y-intercept. Now in this lesson, what you're going to notice is, bringing this over here, if I plugged in x is 0, this term would become a 0. This term would also become a 0, and it would leave me with c. So when x goes in as 0, the c value is always my y-intercept. So the x-coordinate of the vertex. So the x-coordinate of all of our vertices is this new formula. X equals negative b over 2a. So the b obviously is coming from the bx in the middle term. The a is coming from the first term, ax squared. And we're going to plug that in to negative b over 2a to get the x coordinate of the vertex. We're going to start seeing the vertex move. It's not just going to be sitting on the y-axis anymore. So the axis of symmetry, let's think about that, is also going to be that same negative b over 2a. Because remember, the axis of symmetry is really right through the middle of the vertex. So the x-coordinate is not going to change when it's the x-coordinate of the vertex or if it's now the line of symmetry. The axis of symmetry, remember, is an imaginary line going through the vertex. So once we have the x-coordinate of the vertex, we also have the equation of the vertical line, the axis of symmetry. So let's see an example. So we want to find the axis of symmetry and then the vertex. So the axis of symmetry is going to be x equals whatever that line, that vertical line equation is. The vertex will be the x comma y, which will be where we are either at the bottom of our parabola or at the top. So a couple of quick things before we start doing the work here. This function, 2x squared plus 8x minus 1. Couple of quick things. So we know this parabola is going to open up because this 2 is an a. So that's important to notice. Secondly, what I want to just remind ourselves is this is really ax squared plus bx plus c. Just to make sure we understand where each of our numbers are going to be plugging in. Okay? So first, letter A. To find the axis of symmetry. To find the axis of symmetry, we need to plug in the formula, negative b over 2a. So what is the b? Well, b, in this case, is 8. What is the a? A is 2. So now I just simplify. If I simplify, negative 8 over 4, I get negative 2. So to answer A, x equals negative 2. That is the equation of the vertical line, which is our axis of symmetry. Secondly, I'm just going to get a little space here. Now we want to know what's the vertex. Well, to find the vertex, we already have part of it. We know the vertex is going to be x equals, it's a coordinate. We already have the negative 2. Now we just need to know, well, what is the y when x's are negative 2? So all I do is I plug in my equation. So I just plug in 2. Negative 2 goes in for the x. 8x, the negative 2 goes in for the x, minus 1. Once I plugged in my negative 2, I just go ahead and use my order of operations. So negative 2 squared is 4. Then a negative 16 and a negative 1. I would get 8 minus 16 minus 1, which gives me negative 9. So now I know the y value when x's are negative 2, which makes my vertex negative 2, negative 9. And it's as simple as that. Next, we want to talk about how do I graph one of these. So we've been using tables, and you can still use tables if you want. The one thing about this is when you use your tables, you have to remember, you have to keep going until you see your y values repeating themselves. So now that we have a more complicated equation, we want to kind of start getting away from tables if possible. So what I'm going to do is use this equation, 3x squared minus 6x plus 5, to try to find a couple of key important things before I start just using tables over and over again. So number one, a couple of things just to note. This 3 in the front tells me that my parabola is going to be doing a U-shape opening upwards, and I want to keep that in mind as I'm going. So first what I'm going to do is I'm going to go ahead and find my axis of symmetry. So the axis of symmetry, remember we're going to use negative b over 2a. So I'm going to plug in the b and the a. So you got to be careful here. So negative, my b value is a negative 6. So I still have to plug in negative 6. That first negative doesn't just take away the negative 6. This negative 6 still goes in as negative 6. And then in denominator, I have a 2 times a 3. Now, hopefully you'll notice right away, I see two negatives which are going to become positive, so they kind of negate each other. And I'm going to get 6 over 6, which means a 1. So I know that my axis of symmetry is now a 1, which also tells me that my vertex is not going to be sitting on the x or y, sitting on the y-axis. It's going to be sitting someplace on x equals 1. So now I want to find my vertex. So the vertex, I just take my equation and I plug in that x value that we just discovered, and I figure out, well, where's that going to happen? So 1 squared is 1, times 3 is 3. Minus 6 times 1, which is 6, plus 5. 6 from 3 is negative 3. Negative 3 plus 5 is 2. So I know my vertex is sitting at 1, comma 2. So there's two very important pieces right there that we know. Lastly, what I also know is, what is my y-intercept? Well, there's no math to really worry about here. My y-intercept is the c value. So that tells me my y-intercept is 5. So let's just start kind of graphing some of this to see what it looks like. So there's my y-axis. We know it's opening upwards, so I'm going to just go to this point here. We have our vertex is sitting at 1, 2. That axis of symmetry we don't need to draw, but I just want to show it just so we can kind of see. We know that it was sitting here down at the x equals 1 line, so we know we're going to see that symmetrical thing happening on the parabola around that. So what I would do next is, looking at my y-intercept, it is at 0, 5, which is right here. So there's two of my points just from our little math off to the side. So we talked about having 5 points. Here's an example where I can say, well, I know if this y-intercept sitting right here is 1 away from my axis of symmetry, I think I can then say, there's my third point. And so notice we've done these 3 points without having to make a table. We've kind of found the axis of symmetry, used that, which is the x part of the vertex, to find the vertex coordinates. We also knew the y-intercept. We have our 3 points. Remember to draw a nice, as smooth as you can, curve coming through this. It's not a V, it's a curve. And that is what our graph is going to look like. Then we're asked to describe the domain and the range. Well, there's no restrictions on what we can plug in for our inputs, so all real numbers is our domain. And from the graph, what are we seeing? We are only seeing y values that are greater than or equal to 2. So that would end up finishing the graph and the domain and range. Now we have these 2 new vocabulary words called maximums and minimums. So the y-coordinate, so just the y-coordinate of any point, the y-coordinate of the vertex is called the maximum value of the function when a is less than 0. It is called the minimum value when a is greater than 0. So looking at those 2 diagrams or those 2 graphs kind of makes some sense. When a is less than 0, our parabola opens down. And because it opens down, this vertex is the highest point of the parabola. The maximum is going to be the y-coordinate of that point. On the other side, if I have an opening upwards parabola, the vertex is now the minimum. And we know that an opening up parabola is when a's are greater than 1. I'm sorry, greater than 0. So let's go through and find a couple. So for this first one, tell whether this function has a minimum or a maximum. Well, if I look at my function, we see the a value is a negative number. So without really graphing it correctly, we know if it's a negative number, it's opening downward. That would tell me that this has a maximum value, because the parabola opens downward, which means the vertex is the highest point or the maximum. So then it says to find that value. Well, how do I find that value? So we're going to use those same steps we just did on the previous one. So I would first say, let's start with our axis of symmetry. Negative b over 2a. If I plug in negative 24 is my b value, and negative 4 is my a value. So we got a bunch of negatives here. I see 3 of them, which means my answer is going to be negative. 24 over 8 becomes 3. So there's my axis of symmetry, which means x equals negative 3. So once we have the axis of symmetry, now we want to find the vertex. So remember, the vertex basically is, we have the x part of that, the negative 3. We now just want to find the y value. So I'm just going to plug it in. So there's my function plugged in. I just plugged the negative 3 in for the x. Now I just do my order of operations. I get negative 4 times 9. Then I get a positive 72, and I subtract 19. Negative 4 times 9 is negative 36, plus 72 minus 19. Negative 36 and 72 is a positive 36 minus 19, which gives me 17. So I now know the y value of the vertex is 17, so negative 3, 17 would be my vertex. But this question is just saying, what is the value? So this tells me that the maximum of this function is 17. We did all that work to find the x, to find the vertex, but basically we just want to know what is the y value of the vertex. That is the maximum in this function. So on this next problem, we're going to look at a little bit of a real life situation. We have the suspension cable between the two towers. So that would be this thing right here. That's the suspension cable between the two towers of the bridge. They form a parabola, and it can be modeled by this function. Now, the very first thing I want you to hopefully notice is this function cannot be this picture. So what do we know about our ax squared plus bx plus c? The a in front of ax squared, if it's negative, what kind of a parabola should we be seeing? It should be opening downward. So there's clearly a typo here, so we want to fix that right away. Let's get that kind of washed out. This should be a positive here. This is definitely showing something that would be opening upwards, not opening downwards. And that's going to certainly affect our numbers, and being crazy numbers that they are, we want to make sure we have the right numbers. So anyway, what we're now looking for is the height of the cable above the water at its lowest point. Lowest point with parabolas jumps out hopefully as the vertex. And that would be looking for the minimum in this case because it's an opening upwards parabola. So we're looking for the vertex, which is somewhere in this area here, which would be the lowest point of the parabola, that we can figure out what is that minimum number. So we're going to use the steps we just used in the previous examples. So what we first wanted to look for is what is our axis of symmetry. So we're going to use negative b over 2a. In this one, we're going to plug in some numbers, a little bit of crazy numbers here, but the b is the 0.37. We want to make sure we have a positive there to get to that number. And then when I start putting together those numbers, when I multiply out the 2 times the 0.000098 divided into the negative 0.37, those two negatives will cancel, and this is going to give me approximately, let me just go back and change that because we're doing a little bit of rounding here. Oop, that is not the right thing, that's highlighting. Okay, so we want to erase that. We're really going to be approximating, so we're going to approximate this as 1,888. Okay, so that's the axis of symmetry. So what we then need to do is that's still not giving us the vertex, which is going to end up giving us the minimum, which is the answer we're looking for. So now we've got to plug in this 1,888. So I'm just going to pause the video and plug that in. So there's our function now plugged in with all the 1,888. Then we would use the calculator and we're going to run our numbers, and now our answer is that it is approximately 203. Not exact, but approximately. So to answer this question, what is the height of the cable at its lowest point? It is 203 feet above water. Now, another question that could have been asked here, which hopefully we can figure out pretty quickly, what is the height of the suspension cable at the post? Well, certainly at least of the left-sided post. Well, that would be our y-intercept. So that would be 552 feet if that question was asked. So remember, when we're looking at these functions, there's different things we can come out with. We had to do some calculating to figure that out. But if I had asked for this point right here, which on our graph is the y-intercept, C would be the y-intercept. So it would be 552 feet off the water that is being attached to that left tower. We would assume it's the same on the right tower, but at least on the left tower for sure. And one more example here, looking at somebody launching some water balloons and different levels of how they're going to angle their the elastics to shoot up in the air. These two functions are representing what we are seeing for their heights. So the first group of friends is launching theirs at this function. They're giving us this function. So it's negative 16t squared would be opening downward, which is going to give us a maximum height. And then the second person or second group of friends is launching it for this one, which is shown in the graph. So they've already done this one for us. So this one appears, as it's going by 25s, that it's somewhere around 130, I'm going to guess, for their height. That is the highest one. So we don't know what this one is at the moment. So we want to use what we've just been learning to figure that out. And we're going to kind of just show a quick graph of this. So first we're going to find the axis of symmetry. So we know that the axis of symmetry, x equals negative b over 2a. So in our function, the b value is 80. The a value is negative 16. So that's going to give me two negatives make a positive. So 80 divided by 32, which is 2.5. So I know that 2.5 seconds into this launch, this will be at its highest peak. Okay? We also know back from our function that we left the ground at 5 feet. So when they launched this, that water balloon was sitting at 5 feet when it was let go. Keep that in mind. So now we want to find the vertex so we know what the y value or the maximum is. So again, I'm just going to pause the video for 1 second just to plug that in for us. So now I have this plugged in, and I'm just going to follow through our order of operations. So negative 16, 6.25 is 2.5 squared. 80 times 2.5 is 200, and I would add 5. Then negative 16 times 6.25 is 100, and it's negative, plus 200 plus 5. Negative 100 plus 100, 200 is 100, plus the 5 is 105. So now I actually know where my vertex is. My vertex is actually at 2.5, 105. And maybe more importantly, I also now know where the maximum height is of our water balloon. It is actually going to reach its peak at 105 feet. So the max is 105 feet. So just as practice, showing a quick graph of this, if I was to do up here seconds, and we would go half-second slots, and I would do the same 25s maybe that we did on the previous one just to see how they might compare. We can kind of chart these points. I know the y-intercept is going to be at about 5 feet. We said that from the c value. We know at 2.5, we're going to be at 105. So there's the 2.5, and there's the 105. Which also would tell me that at 5 seconds, we would also be back at 5 feet, because that's going to be that same distance. And if I was to kind of draw this kind of a curve with a little bit of rounding, it would look like that. Okay, in this problem, don't really need the graph at this point because we kind of did the work to find that maximum number. So to answer the question, which was, which water balloon went higher? The higher balloon was the second balloon because it clearly went above the 105 mark. So the second balloon went higher. And that is what we are working on this week, seeing the full y equals ax squared plus bx plus c per quadratics and how they are graphed. Notice that the vertex is what you need to kind of see now changing off of the y-intercepts and the y-axes. First, use that axis of symmetry, the x equals negative b over 2a, to find out where the parabola is going to be either reaching its bottom or its top point. And then from there, find the y value of your vertex. Hope this helps. If you have any kind of questions, please feel free to let me know, and we will talk to you shortly.